Hello everyone, thank you so much for joining us today. Welcome to our May webinar. This month we're talking about Smarter Site Insight with CameraHub. Before I begin, as always, just going to run through some housekeeping notes. We will be having a short Q&A at the end of the session, so please feel free to pop in any questions you have into the question box as the webinar goes along, and we'll answer them at the end. And just to let you know, this webinar is recorded and it will be sent out to everyone afterwards. So now I'd like to introduce you to our speaker today, Dom Quiche. Dom has worked in the instrumentation and monitoring sector for 15 years and has been involved in some of the UK's largest infrastructure schemes. His expertise has been pivotal in championing our award-winning intelligent monitoring solution, InfraGuard, as well as the successful launch of the digital interface node, Senceive IO, G1 2.0, and CameraHub. So over to you, Dom.
Thanks, Emma. Thanks for joining today, everybody, and taking the time out of your busy schedules to listen to this webinar, which is off the coattails of our launch of CameraHub, where like I said, we hope to give you some insights into how the product works and its value in the industry. So some of the topics I'm just going to try and run through today, hopefully won't be any longer than sort of 20 minutes, and we'll have some time at the end for Q&A, as Amna said. I'll give you a quick introduction, mainly around why cameras are important and their growing need within the remote monitoring solution. Talk about some of the key features and the journey that we've been on with our camera over the last 10 years. Discuss some of the key applications that cameras are used in, and talk about some of the case studies as well. So, product introduction. Why are cameras important in instrumentation and monitoring? Remote monitoring is often placed in areas where it's either difficult to access, there's a high risk involved, so you need more sampling, so you need higher frequency of readings, or generally it's a very, very remote area, so you can't get there and do manual assessments. The field solution might be made up of a different series of sensors and a data acquisition and comms unit. Obviously at Senceive it would be a wireless system with a series of sensors sampling, and then they connect through nodes and transmitting back through our gateway. To that same solution, we've added a camera that takes static images, and this is proven integral for many reasons and many different applications. The original sensor, if we really stop and think about it, is the human eye, and visual inspections often provide details that single point sensors cannot pick up. So being able to remotely inspect an asset through imagery is hugely important, and is becoming a growing need within a remote monitoring solution. So it can act in various different ways. The camera serves lots of different purposes. Verification, so verify what you're seeing or being told by the sensors. False alerts doesn't always mean false data. An animal knocking a sensor is a valid reading of what's happening. It just might not mean that it's an actual movement of the asset that you're interested in. So being able to see will allow you to verify what your sensor is telling you and decide what you do next. Context, more often than not, a sensor is a snapshot of a precise point, whether it's a crack meter or a piezometer. Surrounding sensors can also add that context to the overall trend and pattern of what's happening within the asset. But a visual representation gives you that immediate advantage over your site and allows you to make a decision on what to do next. Severity. So maybe you've received an alert from a sensor indicating that there has been some sort of movement, but especially when it comes to sort of geotechnical monitoring, sensors are really about magnitude in relation to their baseline, and they don't always give you an idea of exactly what's happening to the asset. So an image immediately gives you scope to see how severe the movement is or what the potential failure has been. Interpretation, so linked to sort of all three of the above there, but really highlights the fact that assessing an image rarely requires a huge amount of sensor knowledge. You don't need to know how a strain gauge works or how a piezometer works or an inclinometer can be read when you're just viewing an image of an asset. So especially when a system is deployed for an early warning system and time is of the essence, being able to quickly assess it through an image is an extremely valuable asset to that process. And then data itself, the image itself can provide that valuable data record of and timestamp of what was going on at that time, because you might not see everything. You might not see everything in the data in the sensor data. So being able to record it on an image, to annotate that image, is extremely useful as a historical record. Equally, we're starting to look at what we can do with the images and see whether we can pull some more metrics from the images over time and start to treat the camera as a sensor. A vital element here is how the camera interacts with your sensors, how it can react to the readings that are taken and instantly decide what to do next, how it can provide the correct range and the correct fullness of imagery 24/7. So that visual check can be made. So it's not just about a camera, it's also about how it interacts with your solution on site. So Senceive in general, we've been supplying cameras to the field for nearly 10 years now, and we've recently released our third generation product called the CameraHub. Hopefully everybody's seen and heard about that over the last month. Our original offering back in 2015 relied on infrared illuminators, which are both power hungry and restrictive on range. They require quite a strong maintenance program to ensure that the vegetation doesn't grow in front and start to create issues with the image, where they start to focus on that, and at night you start to lose a lot of range. So we realized this quite early on. We didn't have that many deployments at the time. And then in 2020, we released our Edge Hub, which was connected to an external camera. And that has been deployed extensively over the last 5 years across railways, highways, and mining infrastructure. It pioneered our innovative technology of using natural light and exposure time to capture night and day images over long ranges and to the same detail, so that we weren't losing anything between the daytime and the nighttime images. We went away from the illuminator. And all our knowledge and understanding from those products were poured into the CameraHub, which we released last month. During this time, we've collected over 6 million images across live sites across the last 10 years, from up to 1,000 cameras which we have live in the field right now. So that number is growing on a day-to-day basis. So what is the product? CameraHub. As I said, we combined the Edge Hub and the camera into one single unit. We added some key innovations that were fed directly back from our key clients and what we saw within the field. So now we have a choice of low light camera modules for the different environments that you might deploy the CameraHub in. It's fully autonomous for power like before and comms, and it still only requires a 45-watt solar panel to power it all year round in nearly all environments. And I'll talk a little bit about power in a few slides' time. It captures static images either through a set schedule, so you can set it to take images at times of the day that you want to record an image. You can either request it as well through our front end, or you can, as I said in the previous slides, trigger it to take a reading via the sensor network. So it's event driven, which is a real key selling point. We've also brought out our innovative clear lens technology to reduce the impacts of the environmental state that you put it in and improve the image quality all year round. And we've improved the power efficiency. So we have a new low power mode, which I'll talk about in a few slides' time. And also you can see on the picture there, we've got a new button on the front, which allows you to do quick site setup and on-site diagnostics to improve efficiency when you're there. The range is a really important factor when we look at the items that I listed out at the very first slide of why they play an important role, making sure that you can see the asset at all locations at all times of the night, and range is vital to that. We've chosen to remain in monochrome. It delivers the sharpest and clearest images, but depending on what you're trying to monitor, range can be quite subjective, of course, and also the environment that you put it in. And we did this test. You can hopefully see the boulder moving within the image, where we placed a boulder at various distances on this railway track to illustrate what a 250 mil by 250 mil boulder would look like. And our method of capture allows us to get up to 60 meters in this particular occasion, where we can see the boulder right at the end of the track before the curve. And these ranges are night and day, and it's fundamental to our successful deployment of so many of our products, and that's why we moved away from infrared illuminators, because we just don't get the same range at night. So range is key, and maintaining that range 24/7 is and 365 days of the year is vital. One of the key features we've released with the CameraHub is adding a resiliency to adverse weather conditions. As you probably guess, weather plays a huge role in why we monitor in the first place or require a monitoring solution, and often it's not in warm and sunny conditions. So being able to ensure that we can guarantee the reliability and the quality of the images in this inclement weather, either all high humidity conditions or where there's large vegetation, basically all the environments that create moisture and dust. It was a key innovation that we had to tackle. We were getting lots of information from our sites to illustrate that we needed to improve this. So to that end, we brought out new clear shot technology on our lens. So before any image is taken, it removes any moisture and any light dust from the lens before the image is taken. This does this in a matter of seconds, so it doesn't increase the latency. And that's not what you want to do in a high-risk situation where you want your image as quickly as possible. It's an example here of where we put a new CameraHub next to our existing Edge Hub, and the image there, you can see the legacy site where we used to think, oh God, there's lots of fog around, but actually the image from the new CameraHub showed that actually it was just build-up of moisture on the lens, either through condensation, precipitation, dew, evaporation of surrounding vegetation, meant that the lens became cloudy, and you used to think, okay, there's obviously a lot of moisture around, especially at certain times of the year, at certain times of the day. So now we can clear that lens and make sure that we get a crystal clear image throughout the year. As mentioned at the start, remote monitoring is generally deployed in hard to access areas, super remote areas, or very high risk areas where you don't want to have people venturing all the time. So therefore, efficiency on site is paramount, and we wanted to make the product as easy and as simple to set up. So that's why we put it into a brand new form factor, and we added a simple activation and diagnostics actually physically on the product itself to speed up the time that you spend on site. Simple button on the front will power the unit up and commence its connection to the back end, and any field wireless network that it's connected to. You can also press the button for further diagnostics to ensure that it's connected to the right power and it's got the right comms and everything before you leave site. We also wanted to improve the efficiency of the system from a power perspective. We normally put these things in very difficult areas, and sometimes the power gets tampered with, or something happens on site where the power gets disconnected, and we wanted to make sure that the unit can last on its own for long enough that you can get to site and remediate. So we've increased the efficiency, and it can do quite a substantial amount on its own without needing a supply. The batteries are also now interchangeable, and so can be swapped out in the field safely. And as I said, we've designed it to work with a 45 watt solar panel, which will will suit most cases. It will suit most cases, especially here in the UK. But we can add an extra power pack or a large solar panel should we need it. If you're putting it under close to a bridge or close under a canopy of trees. We've also introduced a low power mode. So that's where if the unit is struggling, either due to an issue with its power source or excessive use, it will go into the new mode, but like your laptop, where it will only react to triggered images from surrounding sensors. This means that if it's connected to InfraGuard and it's performing safety critical monitoring, it won't waste energy taking scheduled image that might not be the key point, and it will react to an event from the surrounding sensors and make sure that you don't lose that while you try and remediate the issue. So field equipment has the ability to capture and perform as required, and that's the main release of the CameraHub. But most of our interaction will come from the comfort of our desk or our laptop. And after all, this is a remote system. And so to that end, along with the release of the product, we're also releasing a new image gallery. And this sits within our new web monitor UI and allows a much better interaction user experience, and is the first step along a journey of adding a lot of extra benefits and use and going further with the images that we collect. So the new UI, you'll see that you log on. This is some camera hubs that we have on site. As part of our trials, you can drop down and click on any of the cameras that you might want to look at, and it brings up the thumbnails for the last 24 hours. And like I said, this is a test site that we have. You can then flick through the different days, you can different ranges, and change what ones you want to see, or if you want to go back and look at a specific date, you can do. You can also then select, you can take an image from this vantage point. So you can say I want to take an image from site, and I also want to, and that will show up in chronological order. You can also select an image here. I think this is one where it's taken at about 3 in the morning. Yep. So as you can see, super clear image in the pitch of night. You can download that image. You've got some metrics on the right hand side. We seem to add some extra features on that. You can also select multiple images at the same time, and you can do a mass download if you wanted to store them into a report or somewhere else. Or you can create a GIF or a time lapse, which allows you to do a short visual inspection of anything you might see, and download that as well. So as I said, the hardware is one part, but making sure that it transforms through the back end is also just as vital. So as I said, the gallery is available on our soon to be released UI, where these new features and additions will be added. So in terms of field applications, as I say, cameras play a pivotal role in many geotechnical monitoring applications. They can be a benefit to most systems, where a visual check is a valid part of the process. Where they formed an integral part is probably more so in geotechnical applications, so things like slope failures, rockfall events, drainage issues, and even more specifically where they're linked to Senceive's network intelligence system, so where they're linked to InfraGuard, and they have the ability to capture event-driven images to validate movement, has proven to be exceptionally valuable, and that's where we've seen the biggest uptake over the years. Our cameras have also been deployed as part of structural remote monitoring systems, such as bridge strikes and even track movements. In all honesty, the subtlety of the movements in these types of applications isn't necessarily captured by the imagery, just like it wouldn't be by the naked eye, but it can be used to adjudicate the severity and make sure that you can keep some of these assets working. We've got a bunch of case studies. I'm going to go through quite quickly, where we've deployed some of the camera hubs that we're trialing, and we've got them out on site. So we installed this one in Network Rail, part of a wider rockfall monitoring system, deteriorating limestone rocks falling onto the track below. The CameraHub is linked to those sensors. It will take scheduled readings. It will take triggered readings if one of those sensors picks up a rockfall event. We'll ask the camera to take an image and send that back straight away so that the asset owner can assess. Equally, at another site called Kilsby on the LNW route of Network Rail, part of a wider landslide monitoring. So you can see in the left-hand side of the picture some shallow slope sensors in the background there, looking at potential sliding of saturated soils. The CameraHub is in place, and this is part of 2 or 3 CameraHubs that were installed to ensure that any of those slides don't interact with the kinematic envelope of the railway. And so they're linked to those sensors. They take scheduled images, which we're playing in a GIF on the right-hand side, but also react to those sensors as well. And again, sort of touched on it earlier, but where we've deployed the sensors at a site in Dudley, across a 5-meter cutting, we've got quite strong ambient light. So the way that the camera works is using that ambient light, and you can get extraordinarily good detail. We get up to 60-70 meter range for small objects, as we looked at previously, and it's been powered all year long. I'm stealing this statement from one of our technical guys, who was, one of the main protagonists in bringing the CameraHub to market, and he said to me very profoundly, providing an image, a unit that can take static images in the field is relatively simple. Lots of people say to me, we can go buy something off Amazon and we can go plonk it outside my house and take images. What our products are about, what Senceive provide, is a product that can operate remotely, operate reliably at low power. 45-watt solar panel is not particularly powerful for something that runs all year long and is using up power to take images, send images, and communicate with a wireless network. Something that accepts commands and updates remotely and wirelessly, so it allows you to interact with it from the comfort of your own laptop and tell it what you want it to do next. It can provide the same quality of images, whether it's night or day, provide the same quality of images in all weather conditions. It can also, something that can also connect to a wider stack of sensors, be part of an intelligent network on site, and also a cutting-edge display and be shown in a very meaningful way. And also something that can be installed quickly, easily, and safely. When you put all that together, it is not relatively simple. And that's what we spent the last 10 years perfecting, pouring all of that knowledge that we've gained from the live sites and the millions and millions of images into this new product, so we can better serve the industry and further develop how cameras can play an important part in a remote monitoring system. And that, through some of those boxes at the bottom there, in terms of the clear shot technology, form factor, quicker on-site diagnostics, and the new gallery. So yeah, I just want to finish up on just a bit of a summary here on, the integration of imagery into an assessment is now a pivotal part of the process. Seeing is often believing, and it allows that asset owner to make better decisions by placing sensor movements in context, understanding the severity of them, validating the readings that they're seeing, and simplifying the overall interpretation by looking at an image. Often the reaction of an asset owner is to stop traffic if it's a highway, stop trains, and go and inspect the railway and make sure that it's safe to continue the running of trains. By having a camera on site, it allows that assessment to take place a lot quicker, and removes the costly delays that avoids putting trains on slows or shutting down highways until you can get to site. Because, as I said at the beginning, a lot of the time remote monitoring is put in very hard to access or very remote areas. It doesn't aim to remove the need for a thorough site inspection, it's still absolutely pivotal, but it does remove, things like false positives and prevents delays in simple things like traveling times. With technology and how it's moved on, the ability to have eyes on site much quicker is meaning that we can be more efficient. Brilliant. Thanks for your time today. I think we've got time. Yeah, we've got just about enough time for a few questions.
Yeah, thanks, Tom. Let's have a look and see what questions have come through. Okay, so the first question: how dependent is the CameraHub on GSM networks upload speeds? Will 2G suffice?
That's a very good question. So at the moment, and I mean literally at the moment, if you ask me in a month's time, it might not be the same answer. We are reliant on GSM, and 2G is no good. 2G is being is still used in a lot of parts, and is still used by is kept open for various key infrastructure. We've definitely found out over the last year that this switching off of 3G has provided a few headaches for us. Obviously, it goes on to 4G, but where 4G is not available, it has proved a headache. So we are about to release a SATCOMS version, one that connects with Starlink and allows us to talk through that network. So at the moment, yes, we are relying on GSM, but in the next month we won't be.
Okay. Another one: what can be used as an even trigger, specifically when we talk about rail monitoring and sensors installed on rails?
Yes, so we can trigger the camera to take an image through most of the sensors that we use. So typically it's tilt or the ODS, so to the laser displacement. So when you're looking at track geometry, you can use the tilt for a cross-level reading to wake up the camera and say, I think I've experienced something. Do you want to check this and send an image as validation? As I said, you can use the ODS as well. And we've got a few of our interface range that can also do that. So when I say interface range, it's the range of nodes that allow other sensors to be plugged into. For example, crack meters can be plugged into our interface range, and they can trigger the camera to take an image and supply that as part of any alarm set that gets sent back.
Okay. So another one is approximately how many images will the battery be able to sustain at night with no external power?
Good question. So I'm assuming that you'd like to take images throughout the night with no power and on a full battery. It probably take images every 10 to 15 minutes through one night quite easily. Obviously, the system is powered through solar panels. The solar panel tops up the battery, and then the system runs off the battery. So at the moment, for example, we take readings, scheduled readings every 6 hours, but it can trigger throughout that nighttime period through InfraGuard, so it can trigger the camera to take repeated readings. We never see a loss. Obviously, if you're going through a very dark period, like in the middle of winter, it might not get the battery up to its full power. But again, that's why we've designed things like power packs if you need them. It just depends on the frequency of the way that of the scheduled readings you want. Like I said, we've got one up in Carlisle, and for those of you here in the UK, it gets pretty dark up in Carlisle and a bit wet. And we've had one taking readings every hour throughout the winter, no problem, on a 45-watt solar panel, and actually near quite a lot of trees, so it doesn't get a bag load of ambient light anyway. So yeah, it can do quite a lot of things.
Okay, good. Okay. So another one, is there a suggested service interval for the camera components? Yeah,
we don't. The maintenance on site is probably the most important thing. We don't calibrate the cameras. You don't need to. What's most important is maintaining the vegetation and cleaning the camera lens and the solar panel. And you know, the higher you put it, the more away from vegetation, the less you have to maintain. We certainly found through all of our deployments over the years that dust and pollen and it creates a sticky sort of lens. Now we've got our new technology that clears that, but there's no doubt over years and years and years that will still start to build up. So making sure that you clean those every so often is definitely probably the more valuable side than sending it in to get calibrated. There's not really any need for that. We've got cameras, like I said, we've got cameras that have been out for 5-6 years, which we've never seen. They've gone to field and work perfectly, but they are maintained by the client, maintain the vegetation around them. We like to think that the CameraHub and some of the innovations we've done means that maintenance will go down a little bit. They won't need to do, you know, sort of 6 monthly or yearly maintenance visits to clear veg, because we can repel some of the moisture. So yeah, in general, good site maintenance is probably the best actions.
Okay, cool. So just a few more. Is there anything more you can do with images through post-processing?
This is a very topical question. This product definitely gives us the launch pad to do that, and it's the first like domino piece that we needed to get in. Any machine learning or smart algorithm is only as good as the data that you feed it. So we wanted to make sure that we had a piece of hardware or product that enabled that. So we've got that. We are looking at what metrics we can now pull, you know, what we can pull out of the images to warn people on. So actually it starts turning the camera into a sensor. It's not quite there. As I said, this is the first domino in that process.
Okay, I think this is the last question, and it is, why do you not create color images?
So we actually can, but we choose not to. Monochrome gives us a far sharper image, gives us much more definition, to both day and night. There's lots of products out there that use things like AI enhancements where they use the images that they use they guess the colors, they estimate them. We think that's a bit presumptuous, so we use monochrome. If somebody said, look, we'd like to see them in color, we can actually do that if people want to, because it's just the processing part on how we take the image itself. So we just think that it's much better, it's sharper, gives us the definition we're looking for.
Okay, let's have one last look. Oh, another one has come in. So they're asking, what is the max pixel resolution available?
So at the moment we have a 5 megapixel camera. We're just trialing a 12 megapixel as well. We've got it in the field. It's simply a different module that we put into the CameraHub. I'd say that will be released in the next week or two. It doesn't always correspond to the same pixelation that you see in the imagery, because it depends how the image is taken, the environment, the conditions, the light, and everything else. But it does give you that better definition. So yeah, 12 megapixels is going to be available in the next couple of weeks, but the standard is 5. It offers excellent resolution.
Okay, perfect. Right, then I think we'll wrap the questions up there. Obviously, if you do have any more questions, please feel free to email us, info@senceive.com. We will be announcing our June webinar soon, so please keep an eye out for that. So thank you, Dom. Thank you everyone for joining us today, and I hope you all have a great rest of your day. Thanks all.